Section 13.2, we're going to look at our the third of our conic sections. Remember, there's 4 of them. In section 13.1, we looked at parabola and circle. Section 13.2, we're looking at ellipse. Ellipse would be the third of the 4th conic sections we're going to look at. So here's again the case where you have a flat surface crossing one nap of a cone at a certain angle so that it creates the impression on the outside of the cone, which becomes an ellipse once you project it onto a plane. Now, I also want to mention, by the way, the cone itself is a hollow cone. There's nothing inside. And we're looking at the impression that the surface leaves on the outside of the cone. Okay, here's how you can actually try to, if you want to create an ellipse, you have 2 tacks here, and then there is a string. Remember, the length of this string here is a fixed length, so it never changes. The length of the string doesn't change. So once you hold a pencil and pull it to where there's no slack, and then you can kind of try to go around, and because the fixed length of that string is going to keep you in check, and the resulting impression you're going to get on the surface is going to be an ellipse. Okay, now your exercises, first of all, in section 13.2, looks like you're looking at exercise number 9, number 13, and further on down you have exercise number 27. Okay, so let's take a look at how this is going to go. First, we're going to look at the equation of the ellipse that is centered at 0, 0. Okay, and the HK form, in other words, the H here is, here's HK, and H is 0, and so is K. So H and K are 0 and 0 here. We will see the full HK form in a moment, just down below it. So this is the form. Now, one thing that's highly important when we look at the equation of the ellipse is actually what's on the right side. See that 1 here? This is very important. We have to have a 1 on that side. So if we don't, we need to create a 1. And that's because the way we graph the ellipse, it works when there's 1 on that side. Okay. Now, this is the actual HK form of the ellipse. Notice the form that's directly above it is a special case of a more general case here. So this is a special case. This is more general. When H is 0, this becomes x squared, which is right up there. When K is 0, this becomes y squared, which is directly above. So, and here's how actually the ellipse is drawn. Depending on HK, they generically put it in the first quadrant. So here's the center. The center is that. And then I'll show you how to draw the ellipse and how this A and B and K and all that work together. You don't have to memorize the form of this ellipse. But the equation of the ellipse, that's very important for us, okay? And we need to recognize the form in order to successfully graph it. For all of the conic sections, it's very important we recognize the form of the conic section so we can graph it, because we are not plotting points. We recognize the conic section as the graph of a parabola, circle, ellipse, and later hyperbola. Once we recognize it, then we graph it. So let's take a look at another item here about the ellipse. Here's how the A and B, by the way, work in relation to the ellipse. The denominator is actually right up here is a squared. That goes with x. So that means from the center, you go to the right, a units. You go to the left, a units in a horizontal direction, because a goes along with x. B in the denominator of this fraction goes along with y. So from the center, you go up b units, down b units, and these will give you the 4 points on the ellipse. And the next step is, of course, what they've done here is they've drawn these the ellipse through these points, through these 4 points. Now, just want to mention a couple of things. Oftentimes, we refer to these ellipses as vertical or horizontal ellipses. So what do we mean by vertical? What do we mean by horizontal ellipses? As these diagrams may suggest, looks like this one is because this axis is a vertical. The major axis is vertical, so we call it a vertical ellipse. And here the major axis is horizontal, so we call these horizontal ellipse. Every ellipse has a major axis and a minor axis. The longer of the two is the major. The shorter of the two would be minor. Look at the one to the right of this, the ellipse that's horizontal. The longer axis is the major axis and it's horizontal, and hence the name horizontal ellipse. The shorter of the two is the minor axis. Now also, with every ellipse, you have these, what we call the vertices. So here's one vertex, the other vertex. In the case of a horizontal ellipse, those are the vertices, call them VV prime. So the ellipse has vertices. Now these vertices, by the way, VV prime, are at the end point of the major axis. If you also, there are 2 points here that the book doesn't mention it. These are what we call the covertices. Covertices, which is, vertices is plural of the word vertex. Okay. So that's what these are. These are called, and let me just again make sure I do right so you can read well. They're called covertices. Okay. And so here's the equation again of the ellipse, and we're going to see how we're going to graph the ellipse using A and B. That's exactly what they're doing here. So let's take a look at our example first of all. In exercise number 12, we have x squared over 16, y squared over 25 equal 1. So two things that stand out. First, I have the 1 on this side, so I'm good. The fact that I have x squared plus y squared over 2 numbers, that tells me I'm working with an ellipse. So we recognize the form of the ellipse, the equation of an ellipse. And then how are we going to graph this? Well, once it's in standard form, it's pretty easy. We're going to identify the center of the ellipse here. In this case, the center is at 0, 0, right? Because h and k are 0. And then we're going to go square root of 16. Remember, the number in the denominator, in this case 16, this number corresponds to a squared. 25 corresponds to b squared. So a and b would be square root of those numbers. If you take a square root of 16, we get plus or minus 4. So from the center, I go to the right 4 units, and that's how I get this point. From the center to the right. And then from the center, I go to the left, and you get negative 4 on the left. And then likewise with b here. B squared is 25, so square root of that is going to be plus minus 5. From the center, you go up 5 and down 5. And these are the 4 points that are on the graph of the ellipse. And we're just going to draw a curve right through them. And there we have it. Notice we are not plotting points again. We're just using the knowledge of the equation of the ellipse and using A and B to graph our ellipses. Now the longer axis here is, this is a major axis. See, the longer of the 2 axes. This is horizontal, this is vertical. The longer is vertical, the major axis vertical. So I have a vertical ellipse. And number 16, likewise. Now, one thing about number 16 here, to the right, I did not have a 1. It was 144. So the very first thing I did is I divided by 144. This is to get a 1 on the right side. And I did. So here, you simplify the fraction. 9 is a factor in 144. 9 times 16. So I divided the 9s out. The second fraction, I divided the 16s out. 144 is again is product of 9 by 16, so we crossed out the 16s, and that's how I got the 9 here. And once I have that in standard form, I did the usual thing that we did. We simply, what you call it, we locate the center of the ellipse, which is at 0, 0. Oh, hold on here. Actually, let me correct this one, because this isn't centered at 0, 0. Let me actually fix this in a moment, and then I'll show you how this works out in a moment. Okay, so I went ahead and fixed this. I actually had a graph for another problem there. Sorry about that. So anyway, this is now the correct graph. The center of this ellipse again is at 0, 0. And to graph the ellipse, because the denominator of x is 16, we take square root of 16, 4 units, we go to the right 4, left 4, and then square root of 9 is 3, so I go up 3 and down 3, and that will give me the outline of the ellipse, and then I just drew the ellipse through those 4 points. And there you have that one. Now, let's take a look at another exercise. This one is exercise number 28. In exercise number 28, we're actually given the HK form here. The HK form is x minus 2 squared, y minus 4 squared. So h, remember, h is opposite of what you see in here. Opposite of negative 2 is 2. Opposite of negative 4 is 4. So h is actually going to be 2 and k 4. So the center of this ellipse is at 2, 4. So here's 2, 4. And then we do the same thing. What we do is we're going to take the square root of 25. That would be 5. So from the center, I move to the right 5. I was at a distance of 2 units from the 0. Adding 5 more to it to the right makes it 7. And then from the center, I go back 5. So from 2 going back 1, 2, 3, 4, 5 puts me at negative 3, 4. And then square root of 9 is 3. So you're going to go up 2, 3, up 3, and then down 1, 2, 3. And again, these will be the outlines of the points on the ellipse. And we can just draw that ellipse through the 4 points as you see it. Another example, we have number 32. And this is not in standard form. It is almost in the HK form. However, if you look at the right side, the right number is 36. It is not a 1. So what do we need to do? We need to divide everything by 36 on both sides, which is what I did. And again, you divide 4 and 36, the common factors, you get 9. And 9, 36 common factors divided out leaves me with 4 in the denominator. And now I have the ellipse that's in standard form, the HK form. H is going to be opposite of negative 6. That means 6. K would be opposite of 2, negative 2. And there we have it. I didn't write it this time. Let me write it. The center of the ellipse is going to be 6, negative 2. So I went ahead and actually graphed it. Here's the center, 6, negative 2. And like before, I took the square root of 9, which is plus minus 3. So from here, from the center, I go right 3, left 3. Remember, I'm at horizontal distance of 6 units on the x-axis. So right 3 puts me at 9. Left 3, going back 3 from 6 puts me at 3. And then square root of 4 is 2. So from the center, I went up 2, down 2, and I just drew the ellipse through it. I did not plot any points. And by that, I mean I didn't pick random numbers for x and see what y turns out to be. And there you have it. So this would be the end of this section. So again, to recap, in this section, we learned about the equation of the ellipse, both center at 0, 0, and centered off the origin at HK. And hopefully you followed the work that we did. If not, please go back and review this video, and hopefully it will help you get it the second time.